Here we see a cartoon of the sodium-potassium pump, which is powered by ATP. The sodium is pumped out of the cell and the potassium is pumped into the cell. Sodium-potassium pumps require ATP. The sodium-potassium pumps spread the energy of ATP across the entire membrane in the form of a sodium force. The sodium is pumped out of the cell. The result is an increase of sodium in the extracellular space. And once the sodium is pumped out, it tries to return because of electrical force and the concentration gradient. So here we see multiple sodium molecules being pumped out of the cell. Once they reach a gradient on the opposite side, the sodium tries to return back into the intracellular space. This is a sodium force. The sodium force attempting to return to the cell is able to perform work by carrying other products into the cell, and this is called facilitated transport. Here we see the sodium force carrying tyrosine into the intracellular space. And here we see glucose being carried by the sodium force into the intracellular space. The sodium force is essential also to nerve conduction, and you will hear the term neuroendocrine. This is because the neurologic system and the endocrine system are closely related. The sodium gradient is the main battery for cell membrane function, and this requires careful regulation of sugar, salt, and water. Imbalances of water, glucose, sodium, and potassium can be very harmful.